In this tutorial, I am going to explain how to assign the different types of the load on various elements, structural elements of a 3D building. So for this, you are seeing one 3D building model. So this model already it is created from the literature. So in the literature, one example building is given. So this model you are seeing on the screen, and the different loads given in this example. Just I will explain this total loads. First is the loads on a wall. So that is the brick weight of the brick walls. So external wall thickness is given as a 230 millimeter. Internal wall thickness is given as a 150 millimeter. Then this live load on the floor, it is given as a 3 kilonewton per meter square, and live load on a roof, it is given as a 1.5 kilonewton meter square. Then floor finish is given as a 1 kilonewton per meter square, and roof treatment, that is on a terrace slab, roof treatment given. So its load is given as a 1.5 kilonewton per meter square. So these are the loads given in the example building. Now we'll define this particular load. First of all, we'll define this load in SAP 2000, and then we'll assign this. So what are the different loads given in the example building? So first of all, we'll see how to define this particular load, which are the commands. So command is that here is a define, main command is a define, and in that load pattern. Okay, so this command is, so this is one table is there. So in this table, you just make the list of the different loads to be applied or to be assigned on the various elements of the 3D building. So just make a list. First of all, dead load by default is there. SAP 2000, so automatically assigns that is by default it assigns the dead load. So the user need not necessarily to define this separately. So the first major load is the live load. Okay, so it is a live load. So live load on a floor. So give the name. So that in the type it is a, so it is a usual. Okay, so live type of load, and self-filled multiplier is equals to 0. Only for the dead load, multiplier is equals to 1. That is, the software will take 100%, that is complete dead load on the elements. The live load self-weight multiplier is equal to 0 or except dead load. Whatever the loads we are listing here, so self-weight multiplier will be equal to 0. It means that the magnitude or the intensity of this loading is required to define. So then you just add this. Then second is a live load on a roof. Live load on a roof. This is the second category. So next is comes in the roof live, multiplier 0. Then third, brick wall. Now external brick wall. Okay, so brick wall external, multiplier 0. Okay, sorry. So we have to define this. So it is a brick wall external. Okay, in the type of the load, now it is a super dead load. Okay, so in that category we have to define this. Okay, so it is a super dead load, add this. Then brick wall internal brick wall, so again it is a super dead load, add this. Then brick wall parapet. Okay, brick wall parapet, just add it. Okay, then next is a floor finish, weight of the flooring. Again it is a super dead load, just add it. Then roof treatment. Roof treatment, that is given on the terrace slab. Again it is a super dead load. Okay, so these are the loads given in the example building, or generally in 3D building these are the loads acting. So first of all, we have to define this particular, or we have to make the list of the different loads in the defined load pattern table. Then say okay. Okay, then we will one by one will take this load and assign on the different elements of the 3D building. Okay, first of all, we'll apply the live load. Okay, now in the example, live load on the roof intensity is given different, and live load on the remaining floor, this intensity is given different. So we'll define differently. Okay, so first of all, to assign the load, what is the procedure? First of all, select that particular element, maybe slab or maybe beam. Okay, and then assign it. Okay, now here, this particular window, you just make the plan as a XY plan. Okay, the view must be plan, XY plan, because we are assigning the load on the slab. Okay, now select the slab except terrace slab, So here we can, first of all, this thing we do like this. Now this particular plan is at a level at a z equals to 13.6. So that is at the top slab. Okay, so here we are not assigning the live load. So go below. Okay, next view. So this is a command here. So these are the two arrows. Okay, to move either above or to move below. So now we will move below. Okay, so just click on the down floor. Okay, now we are at the level of 10.5. Then just click at the center anywhere within the panel. So once it is selected, we can see the dotted lines. Then again select the bottom floor. In this way, again select the bottom floor, and in the 3D view also, in the side window, it is a 3D view. So in the 3D view also, we can see all the selected the slabs. Okay, now the three slab, this thing, the slab at the 3 floor levels have been selected, and then assign the loads, assign the live load. Okay, how to assign this? So here assign. Now it is area load. Okay, assign area load, then uniform shell. Then here load pattern, in the drop down list, you just click it, and we will assign the live floor. Okay, how much intensity given in this live floor? So live load, it is a, on the floor, it is a 3 kilonewton per meter square. So here define the intensity. So here it is a 3 kilonewton per meter square. Then apply and OK. Okay, so these are the coordinates of the live load. So first is 0. Okay, so it is in X direction 0, Y direction 0, and in negative Z direction, that is in the downward direction, it is -3. Okay, so load has been applied. Okay, then after this, okay, so it is assigned. Then just click on this particular command. Whatever, this is a undeformed shape. Okay, the name of this, it is undeformed. Just click it. Okay, so whatever these letters you are seeing within the panel gets hide. Okay, so just click here. So this is called as the undeformed. Okay. Now the first load is this thing. First load we have assigned. Next is on the same floors, we will apply the floor finish. We will apply the flooring loads. Okay, so then again select the command. So here one additional shortcut is there. Okay, so that command is here. That is, when we click this, when we use this command, so it is previously selected elements gets again select. Okay, so you just click here. Okay, so the same slab which was previously selected, now selected. Now, so we can see in the 3D view as well as this view. Then again assign, then area load, then it is uniform shell, and now it is just change, it is a floor finish. Okay, it is a floor finish. Okay, floor finish, how much it is given intensity? Floor finish, now it is given as a 1 kilonewton per meter square. 1 kilonewton per meter square. Okay, then apply and OK. Apply OK. Now this load has been assigned. Then again click on a show undeformed shape. Okay. Okay. So second load is applied. Okay. Now we'll apply the load on a terrace slab. Okay. Now there are two loads. So first of all, select the terrace slab. So whatever this plan, you move, go to the next one. So now we are at the level of 13.6, height equal to 13.6. In the 3D view also we can see. Now select the all terrace slabs. Okay. After selection, again, first of all, we'll assign the live load, because live load on the terrace slab is intensity is different. So it is an area load, uniform shell. Now category is live roof. It is live roof. So how much intensity given? Live roof. So it is a, on the roof it is 1.5, right? It is 1.5. So it is 1.5. Now apply and OK. Apply OK. Okay. Then again show in deform shape. Yes. Okay. Now on the same slab, now we will apply what? The weight of the roof treatment, waterproofing treatment given. Its load is also, it is defined. We have already defined. Now we'll assign this. Now go here, previously selected sections. Okay. Then again assign area load, uniform shell, and here it is roof treatment. So how much roof treatment intensity? Roof treatment is this. How much it is? Roof treatment 1.5 kilonewton per meter square. Now it is 1.5 kilonewton per meter square, already is there. So apply OK. Okay, roof treatment. Now the loads on floor slab as well as roof slab, all the loads whatever given in the example, so that is over. We have assigned it. Okay, now we will apply the frame load. That is, we will apply the loads on the beam. Okay, first of all, we'll apply the loads on the exterior beams. Okay, exterior beams, wall load. Okay. Okay. So first of all, select all the exterior beams. Okay, select first of all the exterior beams. So go here, select, then select properties. Now it is frame section. Okay, now beam exterior. So already we have defined all these elements separately. So therefore, in this drop down list, this it is there. So beam exterior, select and close. Now in the 3D view, we are seeing here. So all the beams which are lying at the exterior, peripheral of the building, so get selected. Now assign the load. Now how much load to be assigned? It is a wall thickness is given 230. Okay, now we have to calculate the UDL. We have to calculate the intensity of the UDL due to 230 millimeter brick wall. Now how to calculate this? Okay, now what is the slab thickness? So it what is the slab height? 3.1 meter. For this model, it is 3.1 meter. So 3.1 meter minus beam depth, it is 450. Okay, so it is to this building, it is 450. So minus 0.45. So what is the height of the wall? 2.65. Okay, 2.65 multiplied by thickness, it is 0.23 is the thickness, into 1 meter run into density of the brick wall. So it is given in the example, density of the masonry is a 20 kilonewton per meter square is given. So into 20 multiplied by 20 is equals to, it is how much coming? So it is 12.19 is the intensity of UDL due to 230 millimeter brick wall. Okay. Now we have already selected the exterior beam, then assign frame load. Now assign frame load, then distributed. Frame load distributed. So here brick exterior, select properly. Then here define the intensity as 12.19. 12.19. So it is apply and okay now. It is apply and okay. Now we can see here. So here in this view, now this is a plan view. You just change the view to XZ. Okay, XZ. Okay, now it is vertical view is there. So here we have, it is a load assigned we are seeing. Okay. Now we will apply the load on the interior beam, brick wall on the interior beam. So select therefore all the interior beam. So here select properties, frame section, then beam interior, select and close. So in the 3D views, we are seeing all the interior beams have been selected. Okay, now what is the intensity of UDL due to 150 millimeter thick wall? Okay. Again, for this also beam depth is 450. Therefore, height of the wall becomes to 2.65. Okay, so it is a 3.1 minus beam depth 0.45. So it is equals to 2.65, right? Multiplied by 0.15. 150 is the thickness into 1 meter run into density of the material is at 20. So how much it is? 7.95 kilonewton per meter. Okay, so therefore here it is assign frame load distributed. So it is brick interior, brick internal, and load is 7.95 kilonewton per meter. Apply and okay. Apply and okay. Okay, so this is the interior frame. So this is the interior frame. In the 3D, you are seeing this thing, the blue line. This blue line shows the interior frame. Okay, so this is the load of 7.95 on the interior beam. Okay, so this is also now we will apply the load on the parapet wall. Parapet wall is constructed on the top terrace slab, only at the periphery of the building. Okay, so select the parapet wall. Okay, so here again select properties, frame section. Now here beam parapet. Okay, now beam parapet separately it is not defined. That beam is not defined. So therefore it is required to select the parapet beam. Okay, so close it is. Now it is required to select separately parapet wall. Okay, so how to select it? So this is XY plane. Okay, now so this plan is at Z equals to 13.6, Z 13.6. So select only the parapet wall. So just click on the element. Click on the element. So in this way, just click the parapet wall. So parapet beam have been selected. Now what is the intensity? Because height of the parapet wall is given as a 1.5 meter. So therefore height is 1.5 meter. 1.5 meter into thickness of the wall is 0.23 because it is external. Externally 0.23 into intensity 20. So it is 6.9. It is 6.9. So therefore assign it is frame load distributed. We call this as a brick exterior. Okay, and it is 6.9. It is 6.9. 6.9. Then apply and okay. Apply okay. Okay, so it is a exit. Okay, so this is the now here. So this is what is how much intensity? 6.9. Okay, which category? Beam exterior category. Okay, beam external category. brick wall external category, 6.9 parapet, and this is also beam brick wall external category, but intensity is 12.19. Okay, so this is the load. Okay, now all the loads have been assigned. All the loads have been assigned. Okay, now we'll just check in this thing load pattern.